So this was the motivation for making a case for doing this type of a study. And with most of the studies I'm involved in, the idea is to get a long-term information on variability. The AAB River contributes 12% of all of the river freshwater input into the Arctic Ocean. So it's very important. It's one of maybe 7 large Arctic rivers. There's a gauge here at Sellicart. It's at the mouth of the AAB. And this is where we've got measurements, gauge measurements of flow, but they're pretty short. So these rivers, as a sum, they input a good amount of heat to the Arctic, and the idea is to get a longer picture of the variation, the natural variation of this input. So at Sellicart, there's a record that starts in 1937. This is actually a pretty long record for these Arctic rivers. There weren't gauges, there aren't long gauges on these Arctic rivers. So we don't know what their natural variability is. Tree rings, and this is just a sketch here, a diagram to show that in a typical tree ring series, this record of stream flow might just be a small chunk of the time series that could be covered by tree ring data. So we argue that you can use tree ring data to get a longer term, maybe 3, 4, 5 times. This is an 80-year record of gauged flows. Annually on the AAB River, you could get a record maybe 5 times that long by looking at the tree ring record. So this is the objective, and this is the idea that I proposed to the funding agency to try to look at this. Could we go along the AAB and get tree ring records and get an extension of the record of variability of AAB flows? The agency that went for funding for this is the CRDF Global, it's called, Citizens Research and Development Foundation. It's an interesting agency. This has this goal of promoting safety, security, sustainability through science and innovation. It's a non-profit, private organization, and it came about after the fall of the Soviet Union in early 1990s, in 1992. At that time, there were maybe 60,000 experts, Russian experts, working on nuclear weapons, and another 60,000 working on biological weapons. So the idea behind this particular organization was actually scientist redirection. Let's give an opportunity for scientists in this country in these countries, the Soviet Union, Russia, and the former Soviet republics, to work in their home countries, but work on science problems other than development of weapons, or in selling their weaponry skill to other nations. So this was behind the formation of CRDF Global, which came about in 1995. George Soros was one of the original founders of this. I think he injected $5 million to it, and then the National Science Foundation chipped in a few $100,000, and they helped with reviewing proposals. So they're not large proposals, but they basically give you enough money to do travel and to work with collaboration with some of these other scientists in other countries. And the mission of CRDF has changed, it's evolved over time, but still the general idea is to encourage collaboration between different countries, which to me it seems a very good goal. And even now with Russia, I mean, we hear so many bad things about this country, it's important to try to keep links like we do with the space station and with collaborative research that are positive developments. So, the tree ring team, to get to the team, Irina Paniushkina is an adjunct associate professor in our lab in Tucson. she was born in Russia and went to school. They got her PhD there. Here I am with Julie Edwards. I mentioned her. This CRDF also likes to train young scientists, and especially they, with their research call, they want diversity. And specifically, they want to train women scientists. So as part of this, I needed someone to go with us to Russia. At the time that I was writing this proposal, I didn't have any students, so I talked to one of our previous speakers at the series, Kevin Anchikaitis. I said, Kevin, do you know anybody? Do you have any students coming in that would be interested in going to Russia for this trip? This was last year. And he said, well, I don't know. I've got Julie Edwards applying for a master's program in geography from UCLA. You could contact her. So I did that, and Julie, even though she was not even going to be a student until mid-August of last year, said, yes, I'll go to Russia. It sounds like a good deal. I mean, she's not being paid, but all travel expenses are paid. So this was a wonderful thing to be able to take her there. Finally, the third guy on there, Leonid Nazarov, he's our Russian collaborator. Leonid, he's an ecologist and a hydrologist. He's worked along the AAB River for maybe 30 years. He's now the director of the Tree Ring Lab at the Institute of Plant and Animal Ecology in Yekaterinburg. I don't know how many of you have seen the movie Happy People, a year in the taiga. Yeah, okay. So this is about a village, life of the villagers in a village along the Yenisei River, which is the next river over from the AAB. But the main character in this is this very self-reliant trapper hunter who goes out into the taiga and seems very at home there. Well, Leonid, he's the director of the Tree Ring Lab, and he's a good administrator, but when this guy is in the taiga, he really looks happy. I mean, he seems like he's really in his element there. So that was our team, and I've been working. He came over for a Fulbright scholarship 1 year, a few years ago. That's when we initiated our kind of relationship with and started thinking about these science topics. What I will do in this talk here is move through three different sections, and one, to get you acquainted with this river, the AAB River. We'll take a journey up the AAB from Salikart. Then after that, second, I'll go into what trees are we using and how are we trying to get hydrologic information from these trees. Just what's our conceptual model for interpreting these trees. And then finally, I mean, this is continuing work. This is a project that's still going on. We're still doing some things, and we have ideas. Every time we go to Russia, we see a lot of interesting things and think, wow, this would be cool to study. So we have new ideas that we have come up with. And so that last part, I'll talk a little about some of these intriguing possibilities. So journey up the river, this is the first part. How many people have been to Russia before? A handful, yeah. So it's a big country. I know east to west, maybe it's twice as big, as wide as the US. It's a lot of time zones. But our work, the AAB River is in the western Siberia. So when someone says they go to Siberia, that doesn't exactly tell you where they are, because Siberia is a huge mass. The Ural Mountains divides European Russia, divides Europe from Asia. And the AAB is the first river to the west of the Ural Mountains. So this was our river. This was the Gulf of AAB that I showed on that slide of a satellite photo. The gauge is here at the mouth of the AAB at Salikart. And Leonid's lab is in Yekaterinburg. So this is where we visited last year and where is usually our takeoff spot for going onto the river, for flying up to the to Salicart. If we zoom in then to the AAB River watershed, this is a map of the AAB River watershed. Here's Salicart again. All of our collection, our tree ring collections, were on the lower AAB River, in just an area of maybe a stretch of 500 to 700 kilometers from Salicart. So this box is where we went to do our collections. It's a small part. Of course, it's where all the water goes past, coming out of the AAB drainage. But the AAB is a massive river system. In fact, it's the seventh longest river in the world. And it's got headwaters here. The major tributary of the Irtish has headwaters in China, the Altai Mountains, high mountains in China. There's a mountains, the input, the water in the AAB comes largely from snow, some from glaciers, small glaciers up here. Snowpack in these high mountains along the upper reaches. And then there's also a lot of snow across the taiga, the main part of the basin. So that's where the water comes from that goes past where we're taking our samples. And just to show you how the AAB River varies, the flow varies over the year. This is a plot of the flow, the volume of flow in every month from January to December, and gives you the range. So what's happening in the winter? It's frozen. There's nothing. In the spring, it jumps up, and it usually peaks sometime around June, May or June. It reaches a peak. And this is because this river, it flows from the south to the north. And for river systems like that, the snow, everything melts first in the headwaters. But it remains, so it's getting warmer down in the south here. The snow is melting, the ice is melting, but up here it's still real cold. So the river's still frozen. And what happens is then there's ice buildup. It's like an ice dam keeping this runoff from going downstream. And what's happening here is the ice break in May or June, when all of a sudden that water's all backed up behind the ice, it breaks through, and this is when the AAB River floods. And it's a lot of water. These units here in June, the peak here is about equal to the flow of the Mississippi River at its mouth. So it's a huge river, but it's got a great seasonal variation. And so we needed to go up the AAB River. Well, we can't take a road because there are none. And the reason is because of this flooding, this annual flooding. It basically turns the whole thing into this massive swampy looking area with water all over the place. So there's the main stem of a river, and then everything else is ponded up. So roads don't go through there. So we have to do it some other way to go up the river. And this was it. The good ship Zoolog, which in Russian means zoologist. It's a ship of the Russian Academy of Sciences. It's a research vessel that Leonid's Institute has use of, and they take ecologists and hydrologists down the river constantly outside the winter season to do work on this ship. You can take maybe 4 scientists and a crew of 2. That's a typical load for this on the ship. It's very well equipped for research. This shows you, below the deck. It's got some problems. It's designed more for people who are like 5 foot high. So, more than once I hit my head on this top here going out. There are bunks down there, so you could have 4 researchers down there. And here I'm working on my laptop, and because it's a research vessel, the crew is very accommodating. So they would, for 2 hours every night, they would start up the engines and run the generator. so that you could plug in your laptop and work. I mean, otherwise they would not want to run these and wait and use oil. So we would have a little time at night to kind of look at some, try to figure out, write our notes and summarize what we had done. In my trip, excuse me, my trip down the river was in 2014, August 2014. Irina went down the river in 2013. In 2013, the river was very low and there were fires all over Russia. This was bad for taking this type of trip because to navigate the Ob, you really want the water to be high so that you can go up these various channels. And even in 2014, the water level was high. There were no fires, so we could go out into the woods, no problem. And the weather was excellent. It seemed only to rain when we were in bed, sleeping, and then it was nice in the daytime. So we had really good luck in heading up the Ob. The Ob is a meandering river, so the river channel's changing over time, over centuries, millennia. On one side, it would be a geomorphologist's dream to go down this river looking at the banks. So on one side, you see the eroding banks where the river is moving in. That's the direction the channel is changing to. And on the other side, you see the grading banks where here the river is moving in this other direction, and the soil is being built up on the grading side. And the youngest part of the soil that's built up has small vegetation in it, shrubs, and then if you go further and further back, you get onto parts of the soil that had been there longer, and you see older vegetation. So you can, almost at every turn of the river, you would see these different cohorts of trees that are marked when they had started. They'd all started at the same time on some soil that had been created on that side of the river. There were vast desolate stretches along here, the river. So sometimes I thought, wow, we're in the middle of nowhere. But then when you think of the map, if you look at the map of Russia, upstream on the Ob River is Novosibirsk, more than 1 million people. Omsk, more than